Um, Welcome, members of Lux OG, and we are um, Lux OG, and today we will bring a webinar from an Oracle Ace, an Oracle Rockstar from Guatemala, my friend Deiby Gómez. Um, we are very proud to bring this webinar for you. And before for you enjoy this webinar, I want to share some numbers. Lux OG, Luxembourg Oracle User Group, was founded in May this year, and with 3 months, we gathered a total of 61 members, and we published 33 articles for several topics like cloud, Exadata, autonomous, middleware, and other Oracle related stuff. So if you want to enjoy this session and upcoming events, please subscribe to our group. And it's a free membership, and be our guest in our upcoming events. Actually, it's not every day that we have an OCM and Oracle ACE director is speaking. So let's learn with him today. Deiby, now it's your turn to speak.
Thank you.
Just share your screen. I will put my microphone on mute.
Okay, just looking for the share option.
Usually it's on left upper side. It's a small button.
Oh yeah, I found it.
Okay. By now, are you? I will put on mute. Thank you, my friend, and enjoy.
Excellent. Hello, everybody. My name is Deiby Gómez, as Rodrigo said. So today we are talking about Flashback PDB in Oracle Database. So some information about myself. I'm located in Guatemala in Central America. Currently, I'm working as Technical Director at IPRC Central America. I am an Oracle ACE since 2013 and Oracle ACE Director since 2015. I have a master's degree in IT Systems Management and some certification in Oracle, like the OCM 11G, OCM 12C, MAA OCM 12C. I appeared in Oracle Magazine in 2014 in November, December edition. I was also Oracle beta tester for version 12CR2 in 2015. That was in San Francisco in the headquarters of Oracle. I have been a speaker in Oracle Open World in San Francisco, United States, but also in Sao Paulo, Brazil, in Collaborate, in Vegas, USA, and some other countries inside Latin America. I was the winner of IOG Select Journals Editor Choice Award in 2016. That was an award that was delivered in Vegas, USA. And my email is there in case you have any question, in case you want to contact me, my Twitter as well. I usually post some information about Oracle articles or Oracle news in Twitter. So in case you want to follow, that is the Twitter account. I was also technical reviewer of the book that you see in the right side of the screen, the Oracle Database 12C Release 2 for multi-tenant. And I was co-author for the book Oracle Database 12C Release 2, Testing Tools and Techniques for Performance Scalability. Both books can be found in Amazon in case you want to acquire them. So, okay, let's start. The agenda for today is just an introduction about how Flashback Database works in Oracle Database 10G, 11G, and then we are talking about how it works in 12CR1 and 12CR2, for local and share undo, and then we will discuss about Flashback Pluggable database for any version after 12CR2. So it's important to understand the history about this feature, because if we understand how the feature has been evolved, we will be able to understand the deepest details of Oracle mechanism. So before to start, I have to to share this slide. So all the information here is my personal opinion, personal comments. It's not related to any customer or even my position, the company I am working currently. The information was modified to cover general information for the community. So after to show this, let's start. I think Flashback technology nowadays is a kind of tool that every DBA knows so far, and I think it's a very known technology. But there are several different ways to use it. So, for example, we have Flashback Database, we have Flashback Table, Flashback Query, for example, Flashback Transaction, and not all of them use the same data source to restore the information. So, for example, if you are using Flashback Database, that relies on Flashback logs. But if you are using Flashback Table, that relies on the recycle bin. And the others, Flashback option, relies on undo data. So as you see, Flashback technology has different ways to work, and not all of them use the same data source to restore the data. So today we will focus only in Flashback database, which is a feature that relies on Flashback logs. So how Flashback database works, sorry for the typo there in the rollback word, usually is used to restore any customer error that was written into the database. So, for example, you have a customer, you have a user that inserts some wrong data or deleted some data from the database, and then we have the database in a state that for us is kind of corrupted, but this corruption is logical, right? It's not physical. And then you use the Flashback database tool that here in this slide is just a kind of a button. And the result is the database in the state before the logical corruption was performed. So I have to say that in order to use Flashback database, you have to have the database in archive mode. Otherwise, you will not be able to use it. So internally in the database, when you are performing some operation, DMLs, etc., some information is written into the buffer cache, and from the buffer cache, Oracle writes the changes in the read log buffer that is downloaded to read logs by the log writer. But also, if we look at the left side, from the buffer cache, we also write data blocks to Flashback buffer that is downloaded to Flashback load by the process that is called RBWR. And this is periodically. It's not like, for example, the log writer that downloads the information from the buffer to read logs at the commit time, for example. With Flashback buffer and Flashback loads, this works in periodically. It's not kind of synchronic. Okay, so internally, we have several flashback logs, let's suppose, but we will focus only in one file. So let's suppose that this in the left side you have the flashback log and it's empty because you have not written any flashback registries into that file. So at the beginning you just have the flashback log file header. So in the file header you have just general metadata of the flashback log file, because we are analyzing only one specific file here and its registries. So when you, when the database, the instance writes some flashback registries inside the flashback log file, basically you have 3 sections per every single flashback registry. So in the left side, you see 4 flashback registries inside one flashback log file, right? So for each flashback registry, you have the information of the flashback registry. And the most important thing is the copy of the data block. And this is the data block, you know, from the data file. It's not related to flashback, no, it's the clear data block. And also you have a header for that block, which includes some information for that specific data block. And this is repeated for every single flashback registry, as you see in the left side of the slide. So this is just the concept. This is how internally the flashback log file is composed. So let's move from the concept to the reality, basically. So this is kind of internal information of one flashback log registry, flashback log registry. So there are 3 important parts that I have to highlight here. The first part is the information of the flashback log registry, which is the first part that we saw here. If you see, I'm not sure if you look my cursor, but I am pointing to the first section of one flashback registry here. So you have information of flashback registry, block copy, and block header. And this 3 section is what we have here internally into the flashback registry. So the second section is a data block copy, which is an exact copy of the data block from one data file that was modified in the buffer cache, and then it was written to flashback buffer cache as well, and periodically was downloaded to flashback log files. And finally, the third section is the block header, which includes information of the data block copy, right? And the other section is just a dump of the block, basically. Okay, so how the instance recovery works. So basically, for instance recovery, we have 2 phases. The first phase that is performed is rolling forward, and the second phase is the rolling back. So in the rolling forward phase, we apply redo information to recreate all the changes that was performed into the database. That includes committed operation, but also non-committed operation. So when you perform rolling forward, we restore the total operation, even if they were committed or not. This is important to know here. And the second phase is the rolling back, which basically uses undo data to undo the operation that were not committed. So the goal is that after to apply the rolling forward phase and the rolling back phase, we will have the database in a consistent state. That's the goal. So let's analyze one example here, because with example is the way that we archive in a better way the concept. So here I am analyzing one specific data file. Let's suppose that it is data file number 3, right? And inside the data file number 3, we have one specific block that was changed in five times. So the original value was the version 1. Then we apply some changes, any DML, any operation you want instead of the delete. The thing is that that block changed basically, and it changed to version 2. And then we executed some other DML's operation, and then this block changed to version 3, and then version 4, and then version 5, and then version 6, right? So at the end, we have the data file number 3 with the block number 5 in a version that was reached after 5 DML operation. Let's pause. So now we want to execute a flashback database, and that means that we have to take every single data file to the version that was at the flashback time target that we want to reach, basically. So this procedure will be performed for every specific data file into the database. So that's why we are analyzing only the procedure for one specific data file, right? So let's suppose that we have, after all the changes that were performed to the database, 2 flashback log files were generated. So we have flashback log number 1, and we have flashback log file number 2. And the flashback log file number 1 has the version of the block 2, right? Which is the version in the SCN 101. And the flashback log file 2 has the version 5 of that specific block, the block 5 in the data file tree, right? However, we want to execute flashback database to SCN 103, which is in the middle, right? SCN 103 is the version 4. So we have the version 5 and we have the version 2, and we want to reach the version 4 of that specific data block. So the way that flashback database works here is basically Oracle looks for the latest version of the block that was stored in one specific flashback log file before the version target that we want to reach. So in this case, the latest version, of course, is the number 1. Sorry, the number 2, because the version 5 is ahead of the flashback time target that we want to reach, right? It's ahead, so it cannot be used. And we don't have the version 3, so the latest is the version 2. So the first step is to restore that version, which is just a copy of that data block inside that flashback log file, and we and the instance writes that block into the data file again. After that, we have to apply redo information so that we can recreate all the operation, and that's the way we are able to reach the version 4. So from version 2 to version 4, we recreated the operation using redo information, right? So now we have the version 4 of the block, but that means that we have committed operation there, and we have also non-committed operation. So the database is an inconsistent state. So the last task that we have to perform here is the rolling back phase, which applies undo information to undo the non-committed operation, and the result is the database in a stable, consistent state that is ready to be in open mode. Right? So basically, this is how Flashback database works. And of course, we are only analyzing one single data file and one specific block. But all this procedure is just repeated for all the rest of the blocks that were changed in the rest of the data files in the database. Everything is just repeated. So at the end of this session, I think we will have some time to question and answers. So please write down all your questions you have, and at the end we will be able to discuss the topics. Okay, let's move on. So as I said, it's really good to understand the concept, but also I enjoy to compare the concept with the reality, right? So let's analyze some kind of internal information. So as you see here is we have the information from the alert log of the database. So we are executing one Flashback Pluggable database to one specific time, which is 2016, and then the database start to work. As you see, the first phase that is executed is the rolling forward, right? But after to complete the rolling forward, we have the database in an inconsistent state, so we have to apply some undo information, and that operation is called rolling back phase of the instance recovery, and after that, the pluggable database is ready to open in grade-wide. So here another example, we have a data file, blocks. All these blocks color compose one specific data file of the database. So we execute some DMLs, and before to change the data block into the database buffer cache, the instance grabs a copy, and that copy of that data block is written into Flashback buffer, and then is downloaded by the process RBWR to the Flashback log. So if you see, we are changing two blocks here, where you can identify the blocks by the color. So now in the data file, we have a new version of those blocks, but a copy before the change. A copy of the data block before the change were written into the Flashback log. What you can see in the right side, right? So we have time one, and in the time one we have the data block copy of two blocks. So you execute some more changes. You touch different blocks here of the same data file, and in the time two, in the left side we have two more blocks modified, but in the right side we have two more data blocks written to the Flashback logs before the change. So that's why in the left side you see black color, but in the right side you see the original color, which identifies the original version of the blocks. And we execute one more time the operation. So again, so now we have to execute the Flashback database to time two. And as I said before, the first step is to look, okay, the Flashback time target is time two. Okay, so I have to restore all the data blocks that we have in Flashback log files before the Flashback time target that we want to reach. So that means that we have to restore all the data blocks that we have in the flashback log file. So this is what we are doing here. As you see, we start from a data file with a lot of black color, and then we start to replace those black colors with the original blocks, which means we are restoring those data blocks from the flashback log files, right? So after that, we apply redo information here, and finally we apply undo information, and then the database is in the target in the flashback time target. Okay, some other information. It's very useful. The views. So here I am showing you 3 different views that you can use to when you are working with Flashback technology. So $B Flashback Database Log has general information about Flashback data. $B Flashback Database Stat has statistics of the Flashback usage. It's very good to look into this view. I use it a lot. And then $B Session Log Ops, and you can monitoring the flashback operation by filtering the opnet column with the flashback word. So and also we have the Deiby flashback retention time, which is a parameter that identifies the time that Oracle will try to keep the data into the flashback log, and the value in this parameter has to specify in minutes. And the parameter Deiby recovery file test size, which is the space you use to store all the recovery files. So you have to ensure that you have enough, or you will have enough free space to store all the flashback logs that you are supposed to generate. So, for example, a use case, you have a physical standby, and you want to open that physical standby, perform some changes into that database because you want to test one new version of your application. So you use a snapshot standby, right? And the snapshot standby uses Flashback technology. So that will generate some Flashback logs. So you have to ensure that you will have enough free space in the Deiby recovery file size to maintain all the Flashback logs that will be generated during the time window that you will have the snapshot database in read-write. So here you see one formula. It's a formula that is recommended by Oracle documentation to calculate, how much space you have to assign to the Deiby recovery file size. So the usage of Flashback database. First of all, some history. Flashback database feature was introduced in Oracle 10.1. So it's a very old feature of the database. So all the blocks are registered in the Flashback logs. There are some misconceptions here that some people say that index blocks are not written into the Flashback logs, for example. That undo is not, the changes in the undo blocks are not written into the Flashback logs, for example. But that is not true. Actually, all the types of the blocks are written into Flashback log files, including data blocks, index blocks, undo, segment headers, bitmaps, etc. We usually use Flashback recovery to one specific SCN when we want to test some new application, like the example that I just told you, when you convert the physical standby to snapshot standby, or you use it when you want to fix one user error that causes a logical corruption, or you want to recover recover the database through reset logs. You want to activate a physical standby. That is used when you have databases in 10G, because in 10G you didn't have the snapshot standby feature. And of course, you use Flashback Database Technology when you want to create a snapshot standby, which is the conversion from physical standby to snapshot standby. To convert a logical standby to physical standby, which is really useful when you are doing kind of upgrade, but using the logical standby as transient database. You use also Flashback Database Technology for fast start failover to configure in fast start failover to start testing upgrade with snapshot standby, or instantiate a physical standby database that was destroyed by the failover. Right? So when you use the data guard broker, I'm not sure if you are familiar with that, but there is kind of a command that is reinstantiate one specific physical database. If you execute that command, what actually happened behind the scenes is the Flashback Database Technology. But of course, it's not so good, so it has some limitations. And here some of them. So for example, it doesn't fix physical corruption. As I said since the beginning, Flashback Technology is a solution for logical corruption. It doesn't restore deleted data files. So if you delete the data file from file system, Flashback Database for sure is not a tool that you can use to do that. It's not used to undo a shrink operation in a data file. Also, it's not used to restore roll back a database to a time before a creation of restoration of a control file, and it doesn't restore operations that was executed using the option no login. So you have to be aware of this, because that option no login, in my experience, is an option that is liked by a lot of customers. So the problem is that they put no login in a lot of parts of the operation, but they forget to remove the no login option. So at one specific time, if there is one logical corruption and we want to do Flashback Database, at that time the customer realized that some operations were performing no login, and it will be too late. So be careful with no login. How Flashback Database works in 12c release 1? Basically, it works only at CDB level. That means that if you want to apply Flashback Database to one specific pluggable database, that will not be able to do it. In order to Flashback a pluggable database, you had to apply Flashback to the complete CDB. And that means that all the rest of PDB in the same CDB will receive the Flashback operation as well. So that's why Oracle started to improve that feature, because of course it was not good to hear that at that time. So as I said, here you have this is 12c release 1, just to clarify. So you have a CDB that has two different PDBs, PDB1, PDB2, and the problem of this is that the undo table space is shared across all the PDBs, in this case, across PDB1 and PDB2. So you execute some changes, and those changes are written into, well, the data block of those changes were written into Flashback log files. And at the time you want to apply Flashback log, you restore all the blocks of undo into the undo table space, and then you apply all the data blocks from Flashback log files to the data files in the PDBs. But as I said, it impacts all the PDBs into the CDB. After that, we apply the read information, and you apply the read information again in all the PDBs. And then undo information and the same in all the PDBs. It's kind of a problem, because here we have an undo table space that is shared across all the PDBs, and this was the main cause or the main reason of why Flashback Pluggable database was not able to apply in one specific Pluggable database. The blocker here was the undo table space that is shared. So basically, in the version 12.0 release 1, this way to use the undo table space was called share undo. So before this version, we didn't have this concept about share undo. We just call it the undo table space, and that's it. But now, still, we refer to the undo table space as is it, but now we have two types, share undo, and another type, which is local undo, which it was introduced in 12.0 release 2. So what's the difference? The difference is that in share undo, as the example that I showed before, we have one specific undo table space that is shared, as the name says, across all the PDBs inside the container database, inside the CDB, as you see in the image. When Oracle introduced the all local undo, now we have a lot of advantage. So, for example, each PDB can have its own undo table space, as you see in the image. You see that PDB seed has its own undo table space. PDB1 has its own undo table space, and all the other PDBs as well. But also you have the root container with its own undo table space. So basically, every single container here can have its own undo table space. To configure local undo, unfortunately, we have to reboot the instance, and that means downtime, right? We have to plan it, that operation. The PDB seed can have a custom table space, undo table space, so that new PDB's creation will be created with this custom undo table space. Otherwise, if you don't customize the undo table space in the PDB seed, an undo table space will be created by default called undo1, basically. It's possible to change from local undo to share undo and vice versa, right? Like from share undo to local undo anytime. Just you have to know that you have to reboot the instance. And Oracle Public Cloud uses by default local undo. It's kind of starting in 12.0.2 is the recommended configuration by Oracle. And we see that recommendation because Oracle Public Cloud uses it. How we can configure local undo? It's very simple. We shut down the database. We start it up in operating mode. We execute alter database local undo on. We shut down the instance again, and we start it up in a normal way. So after that, we have to verify that the local undo is now used using the query that I put in the slide. So you have to see that the property local undo enable has the value true. How we can configure share undo is exactly the same procedure, but the only difference is that the command that we have to execute is alter database local undo off. Right? but everything else is exactly the same. And after to execute that command, we can verify the new configuration. Again, looking at the property local undo enabled, and now has to have the value false. Here are some notes that are very important to mention. When we are using local undo and we are executing Flashback Pluggable Database, the Flashback Pluggable Database is performed as if you were executing the Flashback database operation in version like 10G or 11G. I mean, you don't have to do anything special here to complete the operation. Basically, you just put the Flashback database to one specific restore point, and that's it. It's exactly the same way that you use in 10G, 11G, or even 12C R1. But when you are using share undo and you execute Flashback Pluggable database, you have to create one auxiliary instance. Well, actually, the auxiliary instance is created automatically by Oracle, and you just have to specify one directory. And that directory will be used to restore all the data files for the table space that are needed to restore there in order to complete the Flashback PDB operation. So this way to work is similar than the feature recover a table from ARM and backup. If you have used the recover a table from ARM and backup, basically Oracle creates an auxiliary instance, restore, perform all the work that have to do there. So you have to be clear here. If you are using Flashback PDB with local undo, you don't have to worry about. But if you are using Flashback PDB and you are using share undo, you need additional space in order to create the auxiliary instance with all the data files required to Flashback that specific PDB. So here is an example of Flashback database with local undo configuration. So you see in the picture that you have a CDB, and each specific PDB has its own undo table space. And you execute some changes, and those changes, the data block of those changes were written into the Flashback log files. So when you apply Flashback PDB, first you restore all the data blocks into undo table space, but only for that specific undo table space for that specific PDB. So as you see here, you are not impacting any other single PDB, even you are not impacting the undo table space of the CDB root. You are just impacting that specific PDB. So after to restore the data block from the Flashback log files, you execute redo, again, only in this specific PDB, and then you apply undo in the specific PDB. And this is the way Oracle Flashback Pluggable PDB works, starting in 12CR2, in 18C, for example, but when you are using local undo configuration. On the other hand, when you want to do this, but you are using share undo, first you create one auxiliary instance only with those required data file that will be used to Flashback that PDB. That's why in the left, in the right side, you see that the auxiliary instance has not restored the data file for PDB2 because we don't need it. We just restore the data file needed to perform the Flashback PDB for PDB1. So we don't need the data files of PDB2. That's why it's empty. And then in the auxiliary instance, we apply redo, and we apply, after to apply redo, we apply undo, and then we just replace the PDB, the current PDB one, by the PDB one in the auxiliary instance. And that's how Oracle executes the Flashback PDB when we are using share undo. As you see, it's basically the same way to do it, like when you are using recover a table from ARM and back. Okay, step one. First, you have to enable Flashback, and you have to know something here. You enable Flashback at CDB level. You cannot, for example, enable Flashback at PDB level. If you do it, you will receive that error that you see in the slide, which is unimplemented feature. And again, in order to enable Flashback, you have to have the database in archive mode. After that, step two is create a restore point, and you have three ways to do it. First of all, you have a normal restore point, which you created like with the command create restore point and a name of it. Basically, the name is just a nice way to name one point in time, but actually that name is resolved by one specific SCN or one specific date, basically. Another way to create the restore point is to create a guaranteed restore point. So you use the command create restore point, the name of it, and then guarantee Flashback Database. But there is a third way to do it, which is a clean restore point. A clean restore point is a restore point that is taken when the database is closed, right? Because to create the restore point, basically, you don't need to stop the database, you don't need to shut down. But if you want a clean restore point, you first have to close the PDB and then to create the clean restore point, right? What's the advantage of a clean restore point? The advantage is that you don't have to apply the rolling forward phase and the rolling back phase in the instance recovery, because if you have the PDB closed, that means that it was closing in a consistent state. So that's why we don't have to apply those phases. The step three, first of all, you connect to the CDB root. You close the PDB. First, you have to close it, and then you execute the flashback operation. But this depends, right? Depends of if you are using local undo configuration or if you are using a share undo configuration. So depending of this, you will see that you will have to specify a directory for the auxiliary instance, or you just execute the operation and it will be performed normally as if you were using 10G or 11G, for example. After the flashback operation completes, regardless if you are using local undo or share undo, you just have to open in reset log the PDB, and that's it. So this is an example with local undo. So you see first that I am closing the PDB. That's the step one. And then I create the restore point with the command flashback pluggable database, the name of the PDB, to the restore point time 3. Sorry, here I am flashing back the database. Actually, I have three ways to do it. First way is using the restore point name. Second way to do it is to specify the exact time. And the third way to do it is using the SCN. So you can use whatever you want. Actually, the 3 ways is exactly the same. And then you have to open the PDB using recent logs, and that's it. It's very simple. But when you are using share undo, you first close the PDB, and then you execute Flashback Pluggable Database, the name of the PDB. In this case, I am using SEM, but as before, you can use the restore point name or the timestamp. And here you see the closest auxiliary destination, and you specify one directory. And then you see that all the required data files to perform the Flashback PDB are stored into this directory. And after that, you just have to open the PDB in open recent log. But now you see, or now you understand what happened behind the scenes, right? To actually flashback the PDB when we are using share undo. And that's the target of this presentation, is that you understand the concept, the internals, how flashback works, and then how it works when we are using local undo and when we are using share undo. And here is the end of the presentation. I hope you enjoyed. So I have some minutes to discuss questions in case you have it. Thank you very much for your time.
Thank you, my friend. Are you able to listen to me?
Yes.
Okay. Do we have some questions, André?
No question. In the chat, it's no question.
Okay. So you are lucky, Deiby. No one had some
The concept
some
is
questions
very
for you.
clear. Excellent.
Yeah. I want to say thank you in name of Lux OG for you, my friend, and also want to say thank you for everyone who stayed with us along this session. And I want to tell people that there is 2 more scheduled events. One next week from Marian Kuptadze about Golden Gate microservices, and an Exadata specialist, one of our board members, will deliver some sessions on next month. So the first one is scheduled for 12th of September, same time in the CST time zone. Stay tuned and watch the webinars with us. Thank you so much, Deiby. Thank you so much for everyone for being with us.